Hello children, welcome to channel Sube. Children, today I am going to discuss question number 10 from the MCQ part of 2021 Physics new syllabus paper. The given circuit is equivalent to a NOT gate, second one O gate, third one AND gate, fourth one NOR gate, fifth one EXOR gate. So children, this gate is an AND gate. You know, normally an AND gate is like this. It has two input terminals, but what they have done is connecting these input terminals together and converting it into a single input gate. So if you have learnt the lesson properly, you must know that this gate is equivalent to a NOT gate. So in the lesson we learned that. There's nothing we have to derive here. Just you have to recall your lesson. So this gate is equivalent to a NOT gate. So if you have a NAND gate like this, I mean without connecting these inputs together as they have done in the question, so this is the truth table you get from this NAND gate. That means if A and B both are zeros, then here C, that means just as soon as we pass this AND gate, before we go to this NOT gate, in between these two at this junction, say it is C, so it is going to be C, 0, because both inputs are 0. So that is just behave as a AND gate, this one. So we get the truth table of an AND gate. So this one is the truth table of an AND gate: 0 0 0 0 1 0 1 0 0 1 1 1. So that is clear. So after following this, after going through this NOT gate, we get these values from Y: 0 turn to 1, 0 turn to 1, 0 turn to 1, 1 turn to 0. So this is the final output for these two inputs. So we don't need this one now. So final output is like this. So after connecting these two inputs, what happens? After connecting these two inputs, we can give 0 to this input. Say we gave 0 to this input. So what happens when x is 0 here? When x is 0, that goes to this both inputs A and B, so they become 0 as well, like this. Then A0 B0. From this truth table you can select the result A0 B0. C will be 0 and Y will be 1. So here C will be 0 and Y will be 1. So that is the final output. So if we gave 1 to this input, like this, 1, we gave 1. So what happens? Now x is 1. So it gets shared by this A and B, or it goes to this A and B, both become now 1. Then if A is 1 and B is 1, what happens? A is 1, B is 1, like this. A is 1, B is 1. Then C becomes 1, Y becomes 0. C becomes 1, C becomes 1, Y becomes 0. So this is the final result. So now we don't want these intermediate results, only the input and output we need. So this input and output equals to the input and output of an of a NOT gate. You know, A NOT gate behaves like this. If input is 0, output is 1. If input is 1, output is 0. Therefore, the answer is this one. This circuit is equivalent to a NOT gate. So children, now I will show you how to make a NOT gate using transistors and resistors and a battery, because in the structured paper they have asked in past papers, and also in future they might ask. So you need a transistor like this. We say C828 transistor, that is the cheapest transistor, about 15 rupees you can buy from an electronic component shop. So using this transistor you have to use certain resistors. So let us arrange. So you must fix a resistor to the base of the transistor. So this is how you can find out the base of this transistor. So when you turn the transistor so that the number facing you, this number, the terminals, so the back side of the transistor is like this, then the transistor will look like this when you turn it, so that the number is facing towards you. Then the center pin is the collector, right side pin is the base, left side pin is emitter, this one base, this one collector, this one emitter. So here this one collector, this one base, this one emitter. So like that you have to connect. Then we are going to construct a NOT gate. So to construct a NOT gate you have to fix another resistor to the collector like this. Let's turn this on. 10 kilo ohm is okay, it is enough to the both base and collector. So now you need batteries. You can use just pentorch batteries, so 1.5 volt batteries. You have to use 4 batteries if you use pentorch batteries like this, because you need 6 volts, because this is a digital circuit, logic circuit, you need 5 volt, but you can do even using 3 volts, but the standard voltage is 5 volt, therefore you need 6 volt. Then you can use 1.5 volt batteries, 4 batteries of these 1.4 volt batteries. Then you have to connect the positive side like this to this resistor, and the negative side of this battery to the emitter like this. You can use a breadboard. You can buy a breadboard, a small one. It is about 150 rupees. Breadboard is a board on which you can construct circuits easily. So there are some holes like this. You can dip these transistors and resistors into those holes and you can construct the circuit using that breadboard. You don't have to solder all these points. Using a breadboard you can do a project like this. So the base is connected to this 10 kilo ohm resistor, and the collector is connected to this 10 kilo ohm resistor. And if you don't have a voltmeter, you can use a diode. You can use a diode. And you have to fix it here like this with a resistor. 1 kilo ohm is suitable, like this. You have to connect it to the collector of the transistor, and here end of the 1 kilo ohm resistor. This one is 1 kilo ohm resistor. To protect this diode, we use this resistor, and you have to connect it to the negative line like this. Then this terminal is your input. This one is your input terminal, because this NOT gate has a input terminal like this and also output terminal like this. So here the output terminal is this one. To indicate the logic level, we have connected the LED like this. If you have a meter, voltmeter, you can connect it to this pointer. This one is if we say this one is B, if we say this one is A, input is A, so this one here, this one is A, this point is B, so like that. So this is the NOT gate. You can check it using, you have to give voltage here, so you have to use a potential divider like this. Let's take this whole thing to right a little bit. So you have to connect a switch like this and a resistor like this. You can use the same value 10 kilo ohm for this to ground the base of the transistor. So this one is the switch. When you put on the switch, this base become high, because this line connected this 6 volt positive side of the battery. Then if you connected this switch like this, then what happens? This battery positive connect with this base, and there is a base current. There is a base current like this, some amount of current pass through this one also, but there is a current through the base, and then there will be a big current through this collector line. Then what happens? This place, the voltage of this place becomes 0. Then this light, this LED light down, LED light down. That means this place 1, because the current is there, positive 5 volt is here, approximately 6. So then this place is high, or logically we say 1. Then this place is 0 logically, that means 0 volt. So this dot doesn't get any voltage, therefore it doesn't light up. So when input is 1, output is 0, that you can see from this circuit. And then if you switch off this one, this switch, if you switch off this one like this one, then what happens? This terminal doesn't get any positive current because the line is open here, so no positive current. This base is connected to negative side like this, so therefore the logic level here is low, that means 0 volt, 0 logic. Therefore no base current, no base current. When there is no base current, there is no collector current, no collector current. To have a collector current, there must be a base current. Since this switch is off, there is no base current and also there is no collector current. When there is no collector current, but there is the voltage here up to this place. This line is continuous, not broken. So up to this level, the voltage is there. It is connected to with the battery positive. Therefore, this place is as same as the battery positive. So 6 volt is here, approximately 5 volt, let us say 5 volt is here. Therefore so the negative is connected here like this, negative is connected, this one is open, the transistor is open, not conducting, transistor is not conducting, it acts like a open circuit like this. It's open switch, like a open switch. So no current passes through this transistor, therefore this voltage doesn't drop, it is at a higher voltage such as 5 volt. So therefore this diode, this LED is forward biased, so the current goes this way, then LED lights up like this. So here 0, logic level is 0, here LED lights up, therefore it is a logic 1. So when 0 is input, the output is 1. So that is the action of a NOT gate. So you can experiment this. When input is 0, output is 1. So using this LED, and also you can fix this LED to this input also, then you can see whether input is high or low. So the final circuit is like this. When you switch on, this LED lights up and this LED lights down. When you put off this switch to this way, then this LED lights down and this LED lights up. So that is the function of this NOT gate circuit. So this is the real circuit. Exactly, this one is inside this symbol, so this one is a just symbol. So I think you can understand this because I step by step developed this circuit. So the voltages are like this. Voltages are like this. If this switch is off like this, then the voltage here is 0 because it is connected to the negative line. Then no current here, then the voltage at this point is 5 volt, say this one 5 volt because the battery is low a little bit after using some days, say 5 volt, then this place, at this place the voltage is 5 volt, 5 volt, capital V, voltage is 5 volt here at this point when switch is off. When switch is on, I'll draw it in another color. When switch is on like this, what happens? The voltage here is 5 volt because it is connected with the battery positive. now it is connected with the battery positive. So here the voltage is 5 volt. Then there is a current through this base, then there is a current through this transistor also. Therefore this 5 volt doesn't remain, it drops to 0 volt. If the transistor conducts, you can't you can't find 5 volt here. It drops to 0 volt, approximately 0.1 volt, but we can say 0 volt. The junction voltage is 0 volt here then. So logic level, then if the voltage is 5 volt here, the logic level is 1, then the voltage here is 0, the logic level is 0, like that. So if the voltage is 0 here, the logic level is 0. If the voltage is 5 volt here, the logic level is high, that means 1. So that is how this circuit works. So you can make this circuit and enjoy. So that is how we make a NOT gate. So children, now let us do this question 11. An object is placed in front of a concave lens as shown in the figure. The paths of the refracted rays emitting from point A of the object are P and R only, Q and R only, PR and S only, PQ and R only, all PQ, R and S only. So they want us to select decide what are the correct rays. So they have drawn some rays. They want us to select the correct rays out of these 4 given rays. So children, if you have a problem like this, you must know there are 3 rules. 3 rules to draw ray diagrams. So the first one, the ray incident on the optical center goes directly without bending. So let us check whether it is correct, that rule. According to the rule, whether they have drawn this diagram. So from the point A, emitting from the point A, they have said in the question. So if this ray falls on this optical center like this, it must go like this without bending. So according to that, this ray R is correct. According to that, this ray R is correct. This one is correct, you see, because they have drawn it like that without bending. It goes directly forward. So that is correct according to the rule. Then the second rule, the ray incident parallel to the main axis goes across F. So the ray incident parallel to the main axis. So this one is the main axis. So if we take this ray from A, because emitting from A, so this parallel ray must go after refracting from this lens, crossing F, the front side or back side of the ray. So when we extend this like this to backward, so it crosses like this, so that ray is therefore correct. However, the ray should cross the focal point. So then this ray is correct. The B is correct. Then the third one, the ray incident crossing F goes parallel to the main axis. The crossing F means this F. You have to choose this F. So let us take this green ray emitting from A. So towards it is going towards F. F. So we make this turn this line into dash lines like this. So after the lens, it must go parallel to the main axis. So this line is parallel. So it is correct according to that, because they have drawn this black color line Q parallel to the main axis. So that is correct. Therefore that is correct. So after refraction it should go like this. So this one is correct. So let us try this. So those are the 3 rules, that's all. There are no 4 rules. So this ray, what has happened? It goes directly straight without bending, but it is not a ray that that fall on this optical center. It is not a ray that fall on optical center. So therefore it can't go straight like this. It must bend. Only this ray goes straight without bending. So this ray also going leaving the lens without bending. So that can't happen. Therefore it is wrong. Therefore this ray is wrong. So what are the correct ones? P, Q and R only. P, Q and R only. So we can choose P, Q and R only, this one. So fourth one is the answer for this problem. Now let us do this question number 12. The displacement time graph for the motion of an object is shown in the figure. So in the figure, this one is the graph. The corresponding velocity time graph would be best represented by, we have to find out what is the correct velocity time graph. So they have given a displacement time graph. So children, if you are working with a displacement time graph, what is the output? Output we can get from that graph is the gradient. Gradient is equal to the velocity. So children, let us observe this graph closely. So let us mark several points along this graph like this: point 1, point 2, point 3, point 4, point 5, then point 6, like this for a beginning. So let us draw a tangent like this to the graph. So this tangent is valid to this first point, because that is where it is touching. It is touching this first point with the graph. So therefore this tangent is this one is called tangent, the angle. So we have drawn a tangent. So this one is the x-axis. So the angle with this x-axis between this tangent and the x-axis is called gradient. It is the gradient. So gradient increases or decreases along the graph. So if we draw another tangent to this second point like this, it should be symmetrical at this side and this side, symmetrical. So now this tangent is not steeper than the first one, so the gradient is less. Gradient is smaller than the first one. So now let us draw another tangent to this third one. Let us take a new one to this third point. Let us draw a tangent like this. So now it is less steeper than the previous ones. So the gradient also is decreasing little by little. So now this to this fourth point. So this tangent is like this now. So it should be symmetrical at both sides, left and right. So you see now it is symmetrical. If it is like this, it is not symmetrical to this fourth one, because this side is this angle is bigger than this one. So therefore we have to draw the tangent symmetrically to a point. The point should be at the middle of the tangent. So the gradient you have to measure. The gradient you have to measure like this. The gradient is the angle with x-axis. So this one is the gradient. So this angle is called gradient. So gradient is decreasing along this graph at the beginning. So gradient is equal to the velocity. So that means velocity also must decrease, since the gradient is decreasing. So we saw now the gradient is decreasing along this first part of this graph. This one is the second part, this one is the third part. First, second, third. Let us divide this graph like this into 3 parts. So in the first part we saw that the gradient is decreasing. So therefore according to this rule the velocity must decrease in this first part. And also there is a sign for the gradient. There is a sign. If it is tilted to this right side like this, right side like this, so the sign is positive. Sign is positive of this gradient. So the velocity also must be positive therefore. So if this gradient is tilted to the left side, we can't find any point here tilted left side. Imagine that this graph goes like this. After this time this graph goes like this, then we can find a negative gradient like this, because now the graph is tilted here, tilted, it was tilted to the right side. Now here the tangent is tilted to the left side, leaned left side. So then we say the gradient is, because the gradient is this angle, gradient is negative, gradient is negative. So here we don't get such a negative gradient, therefore everything is positive in this graph. Part 1, part 2, part 3, everywhere the gradient is positive, because it is tilted only to right side, otherwise it is not tilted to any side like this here, and again it is tilted to right side like this in this part as well. So now let us check the first value of velocity. So the first gradient, let us check this first point first of all at this place. This one is the first point. So let us draw the tangent line like this, tangent like this. So it is the gradient is positive because it is leaned to the right like this. So this angle is positive. Therefore the first velocity value also, since this gradient is positive at the beginning velocity also must be some positive value. So therefore we have to choose the graphs which has positive values at the beginning. So this one has a positive value, this one positive, this side negative. So therefore at the beginning it is positive, at the beginning this is also positive, that also correct. At the beginning this one also velocity, the velocity is positive, correct. Here also at the beginning velocity positive, at the beginning velocity positive. So all the graphs are correct according to that. So now let us check that other points also. The gradient, what happens? Gradients little by little decreases along this first part of the graph. Gradient little by little decreases, gradually decreases like that. That means the velocity also must decrease. Since the gradient is decreasing along the first part of this graph, the velocity also must be decreasing. The value must be decreasing, the value of the velocity. So this, in this graph you don't see any any decrease. It is constant here, constant, it is not decreased. So therefore this one totally wrong. Therefore let us delete this one, not necessary, it is wrong. So here also velocity is not decreasing at the beginning, at the first part it is increasing. So therefore this is also wrong. Therefore let us delete it. Then here you see the velocity is decreasing because the gradient is decreasing little by little like this. So therefore velocity must decrease. We know that now. So here now this one is therefore correct. This one is correct for the moment, it is correct. So let us see, let us check the other graph. So this one is not decreasing, wrong. Therefore let us delete it. This one correct, decreasing, the velocity is decreasing like this, decreasing, the value is decreasing from a positive value, so that is correct therefore. So then let us check this second part. What is the gradient? What is the value for gradient? 0, no angle, everywhere 0. It is not leaned right or left like this. It is level, 0. Therefore in this part 0, this one is correct. Again here 0, this one is correct. Then let us check the third part. Let's delete this one. Again you have to draw a tangent like this and check the gradient. So here what happens? This is the gradient, the angle. So let us go to the next point. This point, you have to get the point which is touching the tangent, which is touching the tangent here like this. So this one is the point. So at this point the gradient gradient has been increased. Because here before that point, some point at this place, you see, before that point gradient is like this, and when you go to a point above this, so the gradient has been increased like this, the angle has been increased. So when you go further along this line, what happens? The gradient, the angle increases. Now it is more steeper like this. When you go like this, the gradient increases. So then what we can decide? The gradient now not decreasing, is still positive, but the gradient is increasing. So the velocity must increase, therefore still positive, because it is tilted to left, therefore or leaned left. So therefore still the value is positive and it must increase, the value must increase like this, positive side, in the positive side. So here in the negative side, so the value is in the negative side, this side is negative, so therefore this one is wrong. Therefore let us delete this, not necessary, wrong. This one is the correct answer, then this one is the correct answer. The third one is the correct answer for this question. The question number 12, let us see the answer. Answer is the third one. Okay, the answer is the third one, so it is correct now. So that is how we should solve these types of questions. Children, let us do now this question number 13. An object capital A moving in a circular path, this one capital A, moving in a circular path at a uniform angular velocity. So it moves like this in a circular path at a uniform angular velocity is shown in the figure. The variation of displacement x and the velocity v of the point P, displacement and velocity of point P of projection of the object on the x-axis, projection. What is the projection? The object is this one. The projection of object on the x-axis is this point P. Projection is, you have to draw a perpendicular line from the x-axis to cross this point A, the object A. So if this angle is right angle 90 degrees, so the crossing point is called P, that is the projection on the x-axis, projection of this object. So we call that the projection of object on the x-axis. So this point P, always this line should be perpendicular. We have to keep that line perpendicular to the x-axis always. So I will show you how this projection moves while this object moves along this circular path. So let us draw a circle to this one, like this, little thick. So now I am moving this circle along this circular path. So I am keeping this pen, you can see my pen, I am keeping the pen always at the point P, that is the projection that cross the x-axis. So now this point is moving like this. Point means this A object is moving like this, so I have to keep this pen like this, perpendicularity to x-axis, like this. So what happens? The point P is moving little by little left, that means my pen is moving little by little left, because this pen is at the point P. So this pen is at the point P. Now P is moving, P is not fixed, so point P is moving because the point P is the projection of the object on the x-axis. So it is moving with the object, so like this. So now the object is closer to y-axis, so point P also is closer to the center, 0 point 0 of x-axis. So like this. And now point P is here now. Point P is now here. So like this. It is further moving like this. So point P is also moving. My pen is moving. Always I am keeping my pen at the projection. At the projection point P. So here like this. So now you see point P is moving, that means the projection is moving left. Now very slowly, my pen is moving very slowly because the object is moving left at a very low rate, but it is moving down at a high rate. So like this, it is moving much downwards than moving left. So at this point it is like this, moving down. So point P is here, my pen is here. Now it is moving like this. And now it is little by little, the object is moving little by little to the right. So my pen also, I have to move like this right. So very slowly. Now projection is moving only along this x-axis. Projection is moving only along x-axis. Now we are going, the projection is going towards the center. Now at a high speed, projection is going at a high speed because this object is moving to the right at a high speed than away downwards. So projection also going at a high speed like this. Now object is moving right, then object is moving little by little upwards, so projection also moving to the right like this. So this is sort of animation. You have to look at my pen. So object is moving like this. So the motion of the projection, now you can see from the motion of my pen, roughly. Now at this end, the projection is at this end. So how did this projection moved? You saw it. the projection moved from this side like this, pass in the center to this end, and again pass in the center to right, and again to left, like this. So exactly it is the motion of a simple pendulum, the bob of a simple pendulum. It moves the same way. So you learn this lesson at the beginning of simple harmonic motion. So this is the example all the teachers explain, so that you must have understood by now. The simple harmonic motion is the motion that point P has simple harmonic motion like this, left and right and left and right. We said to and fro. So this object moves along the circular path, but this point P has a simple harmonic motion. So let us look at the answers. So children, now from this full circle, let us take this portion, this part, so that is 90 degrees, quarter of the circle. So that represent, so this length represent, this angle represents in this graph by this part. This part is equal to this angle. So that means here the time is T by 4, because the total time is capital T to cover this circle, then quarter, to cover this quarter you get only T divided by 4. So the time axis we have to mark here T divided by 4. That is not necessary. If you understand that this part represents this part, that is enough. So now the displacement x, let us check the displacement x. So displacement x, what happens, this side is positive, so it must begin from a higher value, because already now P point is here, the point P is here, so it has a positive value at the beginning. So it must have a positive value at the beginning. So here it is correct, a positive value. Here it is wrong, at the beginning it is 0. Here it has a positive value, it is correct, only displacement. Here it has a 0 at the beginning, so it is wrong. Here also 0, it is wrong. So therefore velocity is we don't have to check because the displacement already is wrong. So this one also wrong. Therefore only these two graphs we have to check furthermore. Then these graphs are equal regarding this displacement, equal. Therefore let us now go to velocity. We don't have to check displacement again. Let us go to velocity. What is the maximum velocity of this motion? I said that you have to now imagine a pendulum, simple pendulum, bob of the simple pendulum, like this it oscillates. So the maximum velocity point is this one. You know, at this one end the velocity is very slow. It slowly turns to the opposite direction, but here at the middle point the velocity is very high. So you know that at the middle point. So where the middle point? Middle point is this place. When this point P is here, the middle point is this place. So then this object is here. When the object is here, the point P is here at the middle point, then it has the maximum velocity. So that means after T by 2 time and T by 4 time, after T by 4 time, because it takes T by 4 amount of time to cover this length. So here the maximum speed it should have here. It has zero velocity, so that is wrong. Therefore this one is wrong. because after t by 4 time, so you know that now this time is t by 4. Initially I explained using this graph, this time is t by 4. T by 4, here t by 2, here 3/4, and here total t. So like that. So here the velocity must be maximum. So it doesn't matter negative, because we know that this direction is positive. So this direction is negative. So now the point P is moving towards this way, because the object is moving this way. So the velocity is to left, that means negative, since this one is positive. So the velocity must be negative, you can understand it now, and also maximum. It should show maximum value at this place. So here it is 0, the other thing is it is positive. Both are wrong. Not positive, the positive is 0, it is wrong. What I said is wrong. For 0, if it is 0, you can't say positive or negative. So however, it is positive, it is 0 here, so therefore this one is wrong. It must be maximum. Here it is maximum, so this one is correct. So let us delete this one as well. So it is, even though the displacement is correct, the velocity is wrong. So here both are correct, displacement and velocity both are correct. Therefore the answer is first one for this question. You can see the question number 13, here 13, the answer is first one. So children, let us do now this question number 14 from the MCQ part of 2021 Physics New Syllabus paper. Water rises in a long vertical capillary tube up to a height of 2.0 centimeter. When the tube is inclined at an angle 60 degrees with the vertical, what is the length of the water column in the tube? Let us draw a diagram for this to illustrate the question. So this one is the beaker, water level, water, then the tube like this, tube, the tube is okay. So let us show the water column like this inside the tube. Then just a little okay. So let us mark first of all this level, the horizontal level of this meniscus. So like this. This level doesn't change whatever the angle, that is the rule. This level doesn't change even though we inclined or not, it doesn't matter. The level is fixed, the water level is fixed. So after after turning this tube like this, they have turned the tube inclined like this. So now the tube is this one. So the water level, let us draw, it must meet this level. The water meniscus must cross this level like this. That is the rule. So now you can calculate, because this angle they have given as 60 degrees with the vertical. With the vertical the angle is 60 degrees. So this angle is 60 degrees. This angle is 60 degrees from the vertical. Then say this what they want us to find out is this length along the tube. What is the length of the water column in the tube? What is the length of the water column in the tube? So this length is the length that we have to find out. This length. So let us say it's simple h. It's simple h. So they have given that this height is water rises in a long vertical capillary tube up to a height of 2.0 centimeter. This one is then 2.0 centimeter. Now very easy. You have to just take the component of this h. H cos theta must equal to 2 centimeter. That is the equation. Equal sign. That is the equation. So let us simplify. H cos 60, they have given the angle 60 equals 2 centimeter. Then cos 60 is half equals then 2. Then h equals 2 times 2, 4 centimeter. So that is the answer. This one, the fifth one. So we are discussing the question number 14. 14 here, the answer sheet is this one, 2021. 14, the answer is fifth one. So it is correct. Children, let us do now this question number 15 from the MCQ part of 2021 Physics New Syllabus paper. Consider the following statements regarding the movement of inertia of a body. Capital A, it depends on mass of the body. Capital B, it depends on the mass distribution of the body. C, it depends on angular velocity of the body. Of the above statements, only A is true, only B is true, only A and B are true, only B and C are true, all A, B and C are true. So they talk about moment of inertia. So moment of inertia, what is the symbol that we use for moment of inertia? The symbol is capital I. We use capital I. You know the moment of inertia of certain geometric objects, say a disk. If it is a disk, you know the equation for moment of inertia, I equals half times mr squared. This is the equation for a disk. The radius is r, the mass m. So if the mass is m, if the radius is r, we know moment of inertia equals half times mr squared. So here you see m is there, then it can change the value of I, moment of inertia. So that means it depends on mass of the body. It depends on, or if it depends on mass of the body. So that is correct. That must be correct because this variable is there in the equation. And also it depends on mass distribution of the body. What is distribution? Distribution is R. They talk about R because if we take another disk, say it is thinner than the first one, so it has a larger radius than the first one. It has a larger radius than the first one. Say the radius r2. So the mass, say the mass is same. Mass is same. because even though the radius is larger, it is thin. This one is a little bit thick, so the mass can be equal, but radius is larger. So now here the moment of inertia I2 is equal to half times same m but different radius, r2 is squared. So we get different value, we get a different value for moment of inertia than the first value. So that means the radius changed, keeping the mass same, but the moment of inertia changed. So that means the distribution is higher. In this example, the distribution is higher. Therefore, it depends on mass distribution of the body. So that is correct. But it depends on angular velocity of the body is wrong. It doesn't depend on angular velocity. It doesn't. So therefore, the answer is A and B. Answer is A and B. Only A and B are true. So the third one is the answer for this one. Question number 15. Question number 15. The answer is third one. So correct answer is third one. So children, let us wind up for today. Children, I think you are happy. If you are happy, please subscribe my channel, and see you tomorrow. Goodbye.